So hello everyone, I'm Ben Armstrong, Program Manager on the Windows base team. I'm here today to talk about what's new in Hyper-V in Windows Server 2016. Before I get started, people enjoying the show so far? Awesome. Has everyone learned something new so far? That's what I like to see. That's the whole reason why we're here, is to learn new things and hopefully go back to our jobs and try out new crazy ideas that we've heard about at the event. So this today, and I want to set expectations really well before we get in. This is not a deep technical session. This is me trying to do a very quick run through of all the features and capabilities that are in Hyper-V in Windows Server 2016. For a lot of these, I'll be calling out and saying, like, we have a lot of resources available online. If you're interested in this, go dig in further. At the end of this deck, I have a link to what is literally an 8-hour Microsoft Virtual Academy that we did just on this topic. And even that doesn't go as deep as I would like it to go. Genuinely, I think we could do an entire week just talking about, okay, here's all the new stuff that's in Hyper-V, and here's how to use it, and here's all the details. So I do want to just be very clear. You're probably going to be frustrated at some time because I'm going to mention something. You're going to be like, hey, that's interesting. I want to know more. And I'm going to be like, on to the next thing. So please feel free to come and chat to me afterwards. I'm very accessible online. We have a lot of resources. So the real goal that I have today is I just want to make you all aware of, hey, what are the cool things you should be going and looking into and learning more about? So why am I saying that this is so high level? The answer is this is a huge release for us. I have a lot of people who come to me and say, hey, Ben, like, what are the 2 or 3 things that are new in Windows Server 2016 for Hyper-V? I'm like, it's not 2 or 3 things. To give an idea of the size of the release, this is the list of features that we put together of like, this is what we did in Windows 2012 and Windows 2012 R2. Then if we take this and we add on what we did in Windows Server 2016, almost the same number of new features again. So it's a huge amount of investment. And there's also a lot of features which we've been quietly working on behind the scenes for 5, 6, 7 years that are finally coming out to market. So with that, let's jump in and start looking at some of the big area investments. A huge investment, and this is a classic one that we've been quietly working on this for over 5 years now. And in Windows Server 2016, we're finally able to announce some of the cool new technology that we're doing in the space of security. So to set the scene, and I talked about this in one of my sessions earlier this week, there are really 2 big things that drove us to do a lot of work in this space. The first thing is, have no doubt, the world and the online world is less secure than it has ever been. We are seeing a steady increase in both the frequency of security attacks and the complexity of security attacks. We're also seeing a kind of a lowering of the bar of who the bad guys are willing to go after. You know, we're seeing more and more, you know, it used to just be, you know, the very top companies that the bad guys went after. I was actually just a week before coming here reading about a case where there was this hotel in Europe where they were frequently getting hacked by bad guys, where basically these people would hack the hotel computer system, get in, override the controls, lock all the doors in the hotel, and then basically blackmail the hotel owner to be like, and they would come in and they would do this at like 2 a.m. in the morning, and then they would blackmail the hotel owner and be like, when your guests wake up, they're probably going to want to leave their rooms. Send us $10,000 and we'll unlock your hotel doors. So there's just this incredible escalation on the threat side of things. At the same time, we've been out talking about getting people to use public cloud, getting people to use hosters, getting people to use different cloud services. And one of the very common responses that we would get to people who weren't using cloud was, look, I work in an industry where we have regulations about how we need to handle and protect our data. We can never do cloud. And so from that point of view, Windows Server 2016 is really important to me because we have a suite of technology where we can go and say, look, we understand that you have these regulations, you have these data requirements, but we believe you can use cloud and still meet those requirements. And one of the pillars of this is a stack of technology that we call Shielded Virtual Machine. And Shielded Virtual Machine is basically 3 different technology components that we've been working on coming together to deliver an end-to-end solution. The first, at the lowest level, is in the core Hyper-V itself, we've added support for a virtual TPM. Why is that important? Our virtual TPM gives you the best capability to be able to use BitLocker and encrypt your data, to be able to do attestation and ensure that trusted code is running. So you can very easily go and enable a TPM on a virtual machine now and start using those features and functionality. But that is just the first step of the Shielded Virtual Machine story. The second part of it is we utilize a set of technologies which at its lowest layer is based on a concept that we call isolated user mode. And when you start bringing this into the picture, what we're able to do is we're able to run a virtual machine where we can say, okay, even though this virtual machine is running on this physical hardware, the system administrator for the host cannot interact with that virtual machine in any way. They can't see the screen, they can't use the keyboard, they can't even access it if they hook up a debugger to the system. And the final thing at the top of this stack is a component that we call the Host Guardian service. And the Host Guardian service is the component that is responsible for, 1, storing the keys necessary to access your virtual machine, and 2, ensuring that those keys only get released if a Hyper-V server passes an appropriate set of health checklists. Now, I do want to be very clear and upfront. Setting up the end-to-end shielded virtual machine story is not fun. It is complicated. It is a 70-page white paper and a couple of weeks of your life. Now, for some of you, you're going to be in an industry or in a situation where you're like, yeah, that is worth it. Like, sign us up, let's go do it. And we have white papers online for that. We've been working with a number of customers. For others of you, what you really want to be doing is you want to be going to your local service providers, your local hosters, and saying, hey, when are you going to be providing shielded virtual machines? And saying, when you get this up and running, we're going to have workloads that we're willing to move up there. So the next thing that we've done in this space is actually something that we call Key Storage Drive. And this was a really interesting conversation with our customers. The shielded virtual machine story is all dependent on Generation 2 virtual machines, because we need Generation 2 virtual machines to securely expose a virtual TPM. And we need Generation 2 virtual machines to deliver on a lot of the security promises. But as we were going through the beta program and working with early customers, we had a number of customers who came back and said, hey, I have older virtual machines that don't run in Generation 2. They're Windows Server 2008 R2. And I still have an industry requirement to encrypt the data on that. And we initially came back and said, well, we can't do that because there's no way we can deliver the same security promises on a Generation 1 virtual machine that we can on a Generation 2 virtual machine. And the customers actually came back and said, that's okay. We don't need the same level of security. The regulation requirement we have is just that our data is encrypted at rest. So what that means is if someone gets access to the hard drive and tries to do an offline attack, it should be encrypted. We don't need to protect the runtime. And so to address that need, we have this technology called the key storage drive, which provides you a secure way to store BitLocker keys for a Generation 1 virtual machine. It's not as secure as a Generation 2 virtual machine with a virtual TPM, but it does allow people to meet the requirements. Next thing I'd like to talk about is actually a show of hands. How many people here are familiar with the credential guard work that we've done in Windows 10? I'd say about half the room. So in Windows 10, we did really some amazing work that super fun to demo on stage. I got to do this last year, where when we look at the security threats against Windows today, a lot of them are not your old school, I'm going to try and install a rootkit and mess with the system. A lot of them are just I just want to steal your credentials. I just want to get your username and password and go and wreak havoc with that on other servers. And that is a very hard problem to protect against. And to help protect against that problem in Windows 10, we introduced this feature called Credential Guard, where what we actually do is we utilize the Hyper-V hypervisor to protect your credentials in the host operating system. So that even if you get malware running as administrator in the host operating system, it can't access your credentials. They're securely stored in basically, you can think of it as a private little virtual machine off on the side. Now, this was something that we first released in Windows 10 Desktop. The two things that we have to announce here in Windows Server 2016, the first one is we're making the same technology available on Windows Server 2016. Because you all know you shouldn't do it, but you all know that either you do it or if you don't want to admit that you do it, you'll say, oh, there are people on my team who do it. And that is the number of times that people will be sitting in a server room, will be sitting at a server console, and they'll open up a web browser. It's a terrible idea, but it happens all the time. So this provides a level of protection so that if they get malware, it doesn't get credentials of usually fairly high levels. The second thing, though, that we've done is we've made it possible and very easy to enable this same level of protection for Windows 10 and Windows Server 2016 running inside a virtual machine. Literally, it is just setting 4 registry keys, and now Windows 10, Windows 2016 running inside a virtual machine will reach down to the hypervisor and say, hey, here are my user credentials, can you please protect them? The next thing in security, this is one that I'm actually particularly proud of, is we've done a lot of work to get Secure Boot working for Linux in Generation 2 virtual machines. So another show of hands, how many people here actually know what Secure Boot is and why you should care about it? See, this always makes me frustrated, because it is something really important that we did, and we did a terrible job of marketing it. So I'm going to take a little aside, and I'm going to give the quick sales pitch for Secure Boot. Secure Boot is a technology that we first started doing in Windows 8. And most of you probably know the drill that in the world of malware, the worst thing you can get on a box is a rootkit. And a rootkit is when the bad guys have managed to get kernel mode code permanently installed on your box. And once you have a rootkit, there is nothing you can do to trust that box anymore. Because anything you do, they could potentially be lying to you. And once you have a rootkit, really, your only option is to throw out the hard drive and start again. It's one of the biggest challenges we have from a security point of view. So with Secure Boot, what we did was we went out and we worked with a bunch of our hardware OEM partners. And we said, okay, what we're going to do is we're going to give you the Microsoft certificate. You need to put that in the firmware on your computer, and as Windows boots, we're going to use that certificate to make sure that no one has tampered with any of the kernel mode code. So that when you have Secure Boot loaded, we can guarantee that when you boot Windows, all the kernel mode code is good. So that once you have Secure Boot, if you get malware on a box, it is possible to clean it. So in this space, there are two things that we've been doing. The first one is, having got this in place for Windows and Windows 8, we've been actively engaging with vendors in the Linux world, so Red Hat, Canonical, SUSE, so on, Oracle, to say, okay, let's get the same thing going for you guys so that you have enterprise customers who want to know that their Linux boxes are only running kernel mode code that came from their Linux vendor of choice. And we've been able to go through and do that. The second part of this is we've then worked to get those certificates included as an option on Generation 2 virtual machines. So you can now have the same level of guarantee and security around Generation 2 virtual machines. The final thing to talk about on security, and then I'm going to switch across for a very short demo. I do apologize, I am going to go a bit demo light today because we have just so much content to cover. This is actually a pretty fun one. I hope you never have to see this, but this is a feature that we call host resource protection. So, interesting fact, we don't talk about it often, but it should not be a surprise to anyone here, is here at Microsoft, we run one of the largest public clouds in the world called Azure, and people like to try and hack it. All day long, we have people buying virtual machines, getting virtual machines through different ways, and trying their darndest to hack into Azure. Now, one of the things that I am incredibly proud about is, knock on wood, no one has succeeded. Very proud of my team that, and we've had years of sustained attempts to hack and find bugs in Hyper-V, and no one succeeded in escaping from the virtual machine. That said, one of the requests that the Azure team came to us with is they're like, it's great that no one's escaped from the virtual machines, but man, when people are in a virtual machine and they're trying to break out, they use a lot of resource. And it's really annoying because it can negatively affect the performance of other virtual machines that are running on the host. Like, can you help us figure out something to do there? So we actually spent a bunch of time working with Azure, working with Microsoft Research, and coming up with a set of algorithms to identify a virtual machine that wasn't behaving in the way that one that was running well-behaving software should behave, but was behaving like it had malware installed in it. And if we see those patterns, what we will do is we will, one, just cut back the amount of CPU and disk bandwidth, just throttle back its resources, just to slow it down and make sure it doesn't impact other systems around it. And two, we'll pop some event logs and we put some nice stuff in the UI so that if you ever see this, what you'll see in Hyper-V Manager is you'll just see in the status, host resource protection enabled. And that means that we've detected something weird's going on here. Now, as I said, hopefully you'll never see this. We've had this out in the technical preview builds, and there's only been one customer who's seen this, but this is quite an amusing story. Now, the thing you have to understand is we did all this work primarily for Azure. The CTO of Azure is Mark Russinovich. And Mark Russinovich has this great presentation that he likes to do on the road on hunting down and analyzing malware, which he does inside of Hyper-V virtual machines. And we broke his demo. It was really great. When we first rolled this feature out in the build, 2 weeks later, we get a frantic call from Mark. He's presenting tomorrow, and all of a sudden, none of his demos are working. They're all running incredibly slow. And it took us, an hour or two to figure out that, like, oh, his virtual machine that was crammed full of malware so that he could demonstrate it on stage was activating host resource protection. So we do have a PowerShell switch now where you can go in and turn it off on a per virtual machine basis. It's really just there for Mark. I would not recommend that anyone turn it off on any of their systems. So with that, let's jump over and do some quick demos. So there are three things that I want to show you just on the security one. The first one I'm going to start with is I'm just going to bring up this Ubuntu virtual machine. I'm going to log in, and I'm going to quickly show that this virtual machine is a Generation 2 virtual machine, which has Secure Boot enabled. Now, a key thing to understand is we allow you to, when you enable Secure Boot, we allow you to choose what certificate you should be using. By default, we have it set to the Microsoft certificate. If you're running Linux, you need to change it to the UEFI certificate authority. But having done that, I've got a nice little script here because I always mistype this on stage. But AmiSecure runs this firmware tool that dumps the contents of UEFI and just looks to see, is Secure Boot enabled anywhere? And if I run that, it says, yep, Secure Boot is on, Linux is running. We know that all this code came from Canonical. So nice and simple. Now I want to show you some of the BitLocker and the encryption features. So the first thing I'm going to do is I'm going to look at this Generation 1 virtual machine. Side note, you will notice all my virtual machines have cat backgrounds. I am a firm cat person, not a dog person. I'm sorry if that causes you to give me a lower evaluation score. So this is a Generation 1 virtual machine. And how do you know it's a Generation 1 virtual machine? My favorite way to show it is it has a floppy drive. But if I go into the settings, what I've done is I've enabled the key storage drive. And the key storage drive is basically we attach a really small virtual hard drive to the virtual machine that BitLocker can use for storing BitLocker keys in, but we then on the host encrypt and protect this drive. So what you can see here is I have BitLocker enabled on this drive. If I bring up disk management, what you're actually going to see inside disk management is I have my primary disk here. I then have this small disk that doesn't have a drive letter associated with it. That is my key storage drive, and that's where my BitLocker key is. So it's not a highly secure solution. It's as good as we can do within the bounds of a Generation 1 virtual machine. And if you have a requirement to have data encryption at rest, this enables that. But now let's jump over to my Generation 2 virtual machine. Every virtual machine has a different cat. So if I bring up the settings on this, you'll actually see this one has the TPM enabled. And there are a couple of options here. Once you've enabled the TPM, you can also say, hey, can you encrypt the state of the virtual machine and migration traffic? Now, our number one recommendation if you have security requirements around live migration is that you should be using IPsec to protect your networks. But we have customers in situations where that doesn't work, so you can go in and say, okay, live migration, save state files, protect them. You can also enable shielding. I have not done that for two reasons. One, I didn't want to take the time to set up all the infrastructure necessary to make that work. Two, once you've enabled shielding, one of the things we do is we disable the use of VM Connect because we're looking at the host administrator, which makes this the worst demo in the world. Because I just sit there with a black screen and go, look, there's a VM running, but I can't do anything with it. It's not a great demo. So if I come into this virtual machine, once again, I've got my C drive, I've got BitLocker enabled. This time, if I open Device Manager, I can come in here, Security Devices. This has a TPM. And that TPM, its data is being protected and encrypted on the host. The final thing to point out is I mentioned guest VSM, the credential guard in the guest. I have that configured and enabled here. So all of my credentials are protected so that even if I got some user mode malware running inside this virtual machine, it could not get access to my credentials. So let's jump back over and keep on going. So the next big area of investment, we've talked about security. The next big area of investment is availability. And I really like the topic of the availability work we've done in Windows Server 2016 for a handful of reasons. The first one is it's actually my team directly that owns most of these features, so most of these are mine. The second reason is there are a number of things that we're doing in Windows Server 2016 that I've been wanting to do for almost a decade, so super excited about that. But the third reason is, of all the new features in Windows Server 2016, when we look at availability, there are just a large number of features here that you get for free by just upgrading to Windows Server 2016. Like a lot of these features, like shielded virtual machine, like virtual TPM, you have to go through, you have to enable them, you have to set them up. A lot of the availability features that I'm going to talk about right now, if you just take your existing Windows Server 2012, 2012 R2 deployment, upgrade it to Windows Server 2012 to 2016, and don't change any of the configuration, you will be in a much better place from an availability point of view. So what have we done? The first big thing that I'm really happy about is that we finally have a complete rolling cluster upgrade story for Windows Server 2016. So what this means is, if you have a Windows Server 2012 R2 cluster, you can upgrade it to Windows Server 2016 with zero downtime and zero need for new hardware. And the process is really easy. You just go into your cluster, you one node at a time, you evacuate the virtual machines off that node, you remove it from the cluster, you upgrade it, you add it back to the cluster. And you go through and do that. And while we're doing this, we actually keep the entire cluster fully compatible. So while you're in this mode, you can do live migration, you can use all the tools and infrastructure, so on. We don't let you turn on new Windows Server 2016 features. So we wouldn't let you add a virtual TPM to a virtual machine until you've gone through the whole process, and the final step is you can upgrade the cluster functional level, and that says, okay, you can unlock Windows Server 2016 features. So one of the things I really love about this whole process is I know there's a common painful experience around upgrading a cluster. And I've heard this story a number of times, and the story goes like this. I have a Hyper-V cluster, and I want to upgrade it to a new version of Windows Server. And I go through, and I test it in my lab, and it all looks good. And I go through, and I upgrade a production cluster, and it looks good for 3 days. And after 3 days, all of a sudden, there's a crash on one of the nodes. And I'm concerned this hasn't happened before. The next day, one of the other nodes crashes. Now I'm in full panic mode. I do some triage, I do some investigation, and what I find out is that in my deployment, there's one hardware driver or one piece of management software which seems to have an issue with the latest version of Windows. So I get on the phone to the hardware vendor involved, and I say, hey, like I've got this issue. And they go, oh yeah, we don't support that version of Windows yet. And you're like, I have systems crashing. And they're like, don't worry, we will have a new driver out in 3 months' time. And you're left going, but systems crashing today. So one of the things that I really like about this is you can go through and update an entire cluster, every node, every component to Windows Server 2016. And you can then go, okay, we're going to let this bake. We're going to let this run for a couple of weeks until we're sure that we're getting the stability out of the drivers and the environment that we want. And we're going to hold off on upgrading the cluster functional level until we know this is rock solid. And if you do that, and you hit an issue, you can actually then roll back the entire cluster with 0 downtime. So if you have not upgraded the cluster functional level, you can then just reverse the process and be like, okay, we're going to empty a node, move the VMs off, we're going to remove it from the cluster, put Windows Server 2012 R2 back on it, and roll it back. And we did all that because we wanted to make sure that this is a very safe process, and we wanted to make it as least scary as possible. So upgrading clusters to Windows 2016 is a great experience. Now, underlying this is a key change that we made in the way that Hyper-V handles virtual machine versions. So in the past, when you moved virtual machines across to a new version of Hyper-V, we would automatically upgrade the version. In Windows Server 2016, we don't. So in Windows 2016, the decision to upgrade the version of the virtual machine is a manual decision. So you can bring a virtual machine across, you can keep it at the current version, or you can say, I want to upgrade this and I want to unlock new features. So why did we do this? Well, for 2 reasons. The first one is it was necessary to enable the rolling cluster upgrade story. But the second one is we understand that most of our customers do not go out and update every Hyper-V server in their infrastructure on the same weekend. Most of our customers roll upgrades out through the data center in a staged fashion, and you have extended periods of time when you have multiple versions of Hyper-V in your data center. The great thing about having a virtual machine that is at a previous version is we provide a complete compatibility guarantee. So what does this mean? This means I can sit down at a Windows Server 2016 host and I can say, I want to create a new virtual machine. Can you make it a version 5 virtual machine? And we'll do that for you. And I can go in and I can install my software. I can do whatever I want. I can take checkpoints. I can have save states. And I can take that virtual machine and I can live migrate it from that Windows Server 2016 box to a Windows 2012 R2 box, and everything works seamlessly. And it's all about just making it really easy to work in those situations where you're in the middle of an upgrade cycle. So that's upgrade. But beyond upgrade, we've spent a lot of time looking at what we can do to just make virtual machine availability better. And the story I like to tell here is this was actually just around the time that we were shipping Windows Server 2012, in the year after we shipped Windows Server 2012. I did a whole bunch of customer meetings. I did over 30 customer meetings with different enterprises and different hosters. And I made them all angry at me. And the way that I made them all angry at me was I would go and meet with these people, and they would just be told, like, hey, you're meeting with some people from Microsoft. They want to talk about your environment. And they'd be like, oh, yeah, like, let's do that. And I would come in, and my first question to them would be, so, when was the last time you had a complete cloud outage? And what did that look like? There was one time where I swear I almost got punched because the person looked at me very upset and said, last night. But it was a fascinating process. There was a lot of interesting data we got out of it. The first piece of data was that we met with over 30 large enterprise customers, hosters, so on. Not a single one of them had gone for more than 12 months without having a complete cloud outage. Every single one of them had had a complete cloud outage in the last 12 months. The second one was that when we started digging in and understanding, okay, what is the cause of those? What is the cause of these outages? There were really 2 leading causes of complete cloud outage. The first one was just brief moments of complete network chaos. And there are two stories that came into this. The first story is, and I'm sure many of you are going to relate to this, is that, oh, it's Thursday afternoon, life is good, we've got most of what we want to do for the week, the servers are humming along, and all of a sudden, for some unknown reason, the network stops working. The packets aren't routing. We don't know why. And in the brief 60 seconds, you have, all of a sudden you have alerts firing all over the place, your blood pressure is rising, and before you can even start to diagnose what's going on, it's back. This happens. The data we have says that in the average enterprise environment, that sort of event happens about once every 6 months. Side note, if you're seeing it more than once every 6 months, you probably need better networking gear. But that happens. The other one, and I love this because I've heard this from a number of customers now, and it is always told to me about a colleague who did this. It's never the person telling me who did this, but I've heard countless stories about a colleague who was updating a VLAN setting or a routing table on a switch and typed in the wrong thing and took half the network off the line for 2 minutes and panicked, had to put it back. Always a colleague, never me. But so there are these events where networking goes away just for a brief amount of time. And with Windows Server 2012 R2, that can be really catastrophic for a Hyper-V cluster. Because if networking goes away, we go, oh, we can't communicate with the virtual machine, and we start doing emergency failovers. And so what will happen is a 90-second network outage will cause us to do a hard reboot on all your virtual machines. This is clearly not desirable. So in Windows Server 2016, we've made a very specific surgical change to clustering that we call VM compute resiliency. And what this is if we have network outage happen, and we know that that virtual machine was on that node and it was running, we will wait 4 minutes before we fail it over, just in case the network comes back. So a couple of things to call out here. The first one is, because this surprises a couple of people who try and demo it, that is specifically to running virtual machines. If you have any offline virtual machines, we still just fail them across straight away. The second one is, all those timeouts are configurable. 4 minutes is the default we went with after talking with a bunch of customers. So that was the first class of problems that we encountered. The second class of problems that we encountered, and together these two accounted for like 90% of the cloud outages we saw. The second class of problems we saw was intermittent storage failure. So we're talking about SAN firmware bugs where the SAN just rebooted or it went away and needed to be rebooted. We're talking about, oh, there was a disk failure and I had to do an emergency rebuild on the storage array. A number of situations where the storage was inaccessible. And when we first heard this, we were like, well, there's not much we can do about that. If the storage is gone, the storage is gone. And in talking to customers, the feedback that we got was like, yeah, look, we get it. We understand that if the storage goes away, you can't keep the VMs running. However, our complaint is that we will have a storage outage. It will take us 3-4 hours to address it, to get the array rebuilt, to get things back up and running. And then it will take us days to validate the state of the virtual machines because they all crashed. There was one customer I talked to where they were particularly frustrated because they'd had this experience, but they were a large hoster, and they couldn't log into any of the virtual machines. So they had a situation where they had hundreds of virtual machines got taken down by the failure of a storage array, and they spent 6 hours once the array was fixed getting the virtual machines up and running, And all they were able to do was know that the virtual machine had booted to a login prompt. You know, they had no way to know, like, if the customer had SQL in there, was it running, was it okay, no insight. And they basically had a couple of weeks of having to, bite their fingernails and wait for customer phone calls to see if there were problems with these virtual machines. So in Windows Server 2016, we made a big investment here. We have a feature which is VM storage resiliency. And what this looks like is you have a virtual machine running that's either running on a SAN, an iSCSI device, it's running on an SMB share, any form of remote storage. If we try to send a disk right through and it fails for any reason, rather than sending that failure back up to the guest operating system, where 9 times out of 10 it will respond by crashing, we immediately pause the virtual machine. We pause the virtual machine and we put its status as pause critical storage failure. And we then basically go into a cycle where every 60 seconds we try and replay that storage event. And we will keep on doing that. The default setting is we will do it for up to 24 hours. And if in that 24 hours at any stage the storage comes back, we will just resume running the virtual machine and act like nothing happened. Now, obviously, the virtual machine will be offline during that time, but it won't have crashed. There won't be any data loss. You don't have to go through any recovery process. So the final thing we invested in this space around the clustering improvements is a feature that we call node quarantine. And this wasn't a big hitter. The network and storage thing, that accounted for 90% of the downtime that we saw. But node quarantine was a really interesting problem that we saw. And the really interesting problem that we saw was that we were seeing customers where they would have like a 4, 6, 8 node cluster. And in that cluster, they would have one piece of temperamental, on the way out hardware. And it would be a network card, or it would be a local storage drive, or whatever. And it would be the sort of problem where the hardware would work fine unless you put it under load. And what we saw was when we got these, that one piece of hardware could completely destroy a cluster. Because what would happen is it would join the cluster would start putting workload on it, it would hit its issue, it would crash, it would have problems, so on. In the process, causing everything that was running on it to crash, it would get kicked out of the cluster and workload would get restarted, but then it would reboot or it would get over its problem and it would join the cluster again, and we would be stuck in this repeat cycle where the cluster was constantly putting workload on this problematic node and then having it crash. So with node quarantine, we now have some intelligence around this. And node quarantine is basically 3 things. The first thing is we now track whenever a node leaves and rejoins a cluster without human intervention. So we differentiate between someone sitting down at the console or using a PowerShell script or so on versus, hey, this was just the cluster doing its thing. So we track whenever that happens. And if we see that exceed a threshold, the default threshold that we have, and it's configurable, but the default threshold is if we see this happen 3 times in an hour, we will put that node into quarantine. And quarantine means 3 things. Number 1, if the node comes back and it currently has workload on it that's not crashed, we will move the workload off. So if you have, say, a system with a network card that's failing, and it gets into quarantine, but there are virtual machines running on it, when it comes back into the cluster, we will live migrate those virtual machines off automatically. Then 2, we will not put any new workload on that node. It is now in quarantine. We do not trust it. And 3, we mark it as quarantined in Failover Cluster Manager, and we wait for a human administrator to come in and either permanently eject it from the cluster or to tell us that you've done the appropriate triage and it's now healthy. So that's a whole bunch of work that we've done around the host clustering. We've also been working on guest clustering. So in Windows Server 2012 R2, we came out and we announced the shared VHDX for guest clusters. The great thing about this was that it allowed you to do guest clusters without having to do LUN management, without having to use iSCSI, without having to use Fibre Channel. The downside of it was you still took on all the limitations of guest clustering. There were a bunch of features that did not work with guest clusters. Well, in Windows Server 2016, we've closed a bunch of those gaps. You can now do shared VHDX online resize with a guest cluster. You can do host-based backup with a guest cluster. You can do a host-based replica with a guest cluster. In fact, in Windows Server 2016, the only thing that you can't do with a guest cluster that you can do with a standalone virtual machine is storage migration. I'm hoping we get to that in the future. But the real goal here is that we just want to make guest clusters as easy to manage and as easy to use as standalone virtual machines. And speaking of Replica, this is a small change that we made in Replica, but an important one. We made some changes around how Replica responds to hot add and remove of virtual hard drives from virtual machines that are being replicated. In Windows Server 2012 R2, we added the ability to hot add and remove virtual hard drives, but it would cause all sorts of problems if you were using replication on that virtual machine. In Windows 2016, the 2 key changes that we've made here, the first one is Replica now has its own separate list of virtual hard drives that it's replicating, so that if you hot add a virtual hard drive to a virtual machine that's replicating, it's fine. It doesn't get replicated by default, but it doesn't upset the rest of the replication. The second thing, though, is we now allow you to change that replication list on the fly. So it's very easy if you've hot added a virtual hard disk to go like, and I want this included in replication. Then there are a bunch of features that we did which are just about allowing you to do things while a virtual machine's running that you used to have to turn it off for. So I'm going to jump through these very quickly. The first one is we now let you add and remove virtual network adapters from virtual machines while they're running. Incredibly handy. Another one is we, in Windows Server 2008 R2, we implemented the feature dynamic memory, where we allow people to say, hey, I'm either going to assign a static amount of memory or I'm going to let Hyper-V dynamically adjust the memory as appropriate to the virtual machine. Well, we had customer feedback about, I want something in between those. I still want flexibility, but I want to be in control. And so now in 2016, we allow you to change the memory for static virtual machines while they're running as well. So even if you're not using dynamic memory, you can still go in, increase, decrease, mess around with the memory allocated to the virtual machine while it's running. The final thing from an availability point of view is we made a bunch of changes to checkpoints. So I have to tell a bit of a story here, because checkpoints is a feature near and dear to my heart. It's a feature that my team has owned since its inception. And when we first released the very first version of Hyper-V, it had checkpoints for virtual machines. And there were a number of aspects about checkpoints that we knew meant that they weren't safe to use in production. The way they were created, the way they used disk space, the impacts on performance, and so on. And we had a big debate about this, and we were like, no, it's fine. What we're going to do is, this is really important for development and test environments. We're going to do it for development and test, and we're going to put in our best practices that you shouldn't use checkpoints in production environments. We're going to put in our documentation that you shouldn't use checkpoints in production environments, et cetera, et cetera, et cetera. And no one listened to us. And everyone used checkpoints in production environments. 12 months after the first version of Hyper-V shipped, our #1 support call generator was people shooting themselves in the foot using checkpoints in production. Let me tell you, if you're the program manager who owns a feature who's the #1 support call generator, you get to meet the vice president. It's great. We have a meeting every 3 months where like the top 12 support call generators get to meet the vice president, and you get to put together, like, explain to the vice president of your org, you get to explain to him what your plan is for reducing your support call burden. So we've been slowly chipping away at this. With every release of Hyper-V, we've been making changes and making refinements to make checkpoints safer in production environments. And finally, in Windows Server 2016, we are now at a stage where we can say, yep, these are completely supported in production environments. So what are some of the changes that have been made, and what's been the final step in Windows Server 2016? Well, we made changes to the way that we lay out the hard drive files, where we store them. We've done a lot of performance work to make sure that the performance is acceptable. In Windows Server 2012, we finally added the ability to live merge in changes when you remove a checkpoint so it doesn't use up space needlessly. But one of the outstanding problems that we've had is that when you take a checkpoint of a virtual machine, we capture all the memory state of the virtual machine. This is incredibly handy in a development and test environment, but it's really problematic in a production environment because you don't want to roll an Exchange server back to the memory state it had 3 hours earlier. You don't want to roll a SQL server back to the memory state that it had 3 hours earlier. So to deal with that, we now have this option in our UI to use production checkpoints, and it is the default setting now. And what happens with production checkpoints is you go through and you use Hyper-V just like you've always used it. There's a nice little checkpoint button there. You hit checkpoint. We ask for the name of the checkpoint, and we create a checkpoint point in time. But what we've done is instead of capturing the memory state, we utilize VSS inside the virtual machine to essentially do an instant backup of the virtual machine. And now, when I say I want to restore that checkpoint, instead of coming back with all the processes, with all their in-flight network communication and so on, we boot the virtual machine, and all the enterprise software inside it believes, oh, I've just been restored from a backup. I know what this looks like. And it goes through, and it does the checks and so on. Your data is protected, but it is completely safe for production. Now, we know that there are lots of times when you do want to capture the memory state for a virtual machine, so we still provide the standard checkpoint option, and you can go in and select that and say, I want to use standard checkpoints for this virtual machine. So now I'm going to very quickly I am not going to demonstrate 90% of what I just showed you because I could easily run out my time just doing that demonstration. What I am going to do is I'm going to quickly just do some hot add and remove demos. I do have a cluster here that I was going to do, but I'm going a little over time. So let's bring up this, and of course it's set. There we go. So this is just a Windows Server 2016 virtual machine that I've got set up to do hot add and remove. So two things I want to show. Bring this over here. If I bring up Task Manager inside this virtual machine, you can see it's currently configured with 900 meg of memory, because apparently I forgot to fix up after my last demo. But it's using static memory. I can come in here and just say, okay, we need more memory. There we go. Nice and simple and done. Now, one of the things I really like about this is not only do we let you add and remove memory, but one of the features I love about dynamic memory is the memory pressure. So keep in mind, this is a virtual machine that's set with static memory. Dynamic memory is disabled. But we now show you the memory statistics about the memory demand. Why is this so useful? It's so useful because we've all had this situation. We've all had a situation where we've had to create a virtual machine for someone else, and we've been like, how much memory does it need? And they're like, oh, 8 gig. We need 8 gig of memory. And you're like, I think you're just running IIS in there. I don't think you need 8 gig of memory. But it's really hard to have the conversation with them because like, nope, it's on a physical server today. It has 8 gig. I need 8 gig. So now in Windows Server 2016, you can go, fine, I'll give you 8 gig. Let's get it up and running. And then you can come and you can look at this data right here and go back to them in a month's time and be like, hey, I've been monitoring your system. It only ever uses 800 meg. So we're going to drop it down to 2 gig, and it's going to be fine. It's a very handy tool. The other thing to show is just the hot add and remove of network adapters. So I'm going to bring, oh, I already had this open. So once again, this is really simple. I just come into the settings, and I can add as many network adapters as I want. Actually, I can't add as many network adapters as I want because Hyper-V only lets you have 8 network adapters per virtual machine. So I have to keep count. If I try and add too many, again, error message. But go ahead and apply these, and we're going to go and just add these while the virtual machine is running, and we'll see network adapters popping up in the network connection dialog. There we go. So nice, simple, and equally I can remove them while I'm running. So I don't actually need 7 network. Oh, actually I did all 8. Fantastic. I counted right. So there we go. All network adapters gone. So I'm going to jump back over to the deck. We have a ton of content to cover. I hate this. This is my session for running slightly over time. I apologize. So storage. A lot of investments here. In Windows Server 2012 R2, we provided the basic infrastructure for storage QoS. So the ability to start controlling how much storage bandwidth the virtual machine gets, limiting it, and placing reserves. In 2016, really the big change that we've made here, there's been a number of small changes, but the big change is we now allow you to specify grouped storage QoS policies on a Windows scale-out file server. So why is this important? It's important for 2 reasons, and it's all about what does it look like when you scale out storage QoS controls. And we have 2 types of policies. The first one is a single instance policy. And the idea about a single instance policy is, let's say you're managing your private cloud infrastructure for a company where you have multiple divisions and you have different divisions always complaining about those jerks in engineering are always doing crazy things and making my finance virtual machines run slow. Well, with single instance storage QoS, what you can do is you can go, okay, look, I know my backend storage array is capable of 40,000 IOPS, and I'm going to go, engineering team, I'm creating a single storage QoS policy for you. It is 10,000 IOPS. We're going to tag any engineering virtual machine with this policy, and you guys can do whatever you want, but now their virtual machines are effectively competing with each other inside that 10,000 IOP bucket and not affecting other virtual machines. So that's the first policy we've enabled. It's what we call the single policy. The second one is what we call the multi-instance policy, and this helps deal with the problem of I have 400 desktop virtual machines, and I set a storage QoS policy on each of them that gave them 300 IOPS. We've got better storage, and now I want to update all of them to 400 IOPS, but I don't want to have to go and change the setting on 400 virtual machines. So the multi-instance policy is just a way to be like, okay, I'm going to create a single policy, which is my VDI worker policy. And then I can tag all these virtual machines with my VDI worker policy, and when I need to change that, I'm just changing it in one place. Another big investment in storage is the work we've been doing around direct device assignment. So there's a new class of storage coming out that you may or may not be familiar with, which is called NVMe storage. And one of the challenges that we have with NVMe storage is it is incredibly fast and incredibly low latency and when you start using NVMe storage, virtualization starts adding a significant overhead. So for people who need the absolute highest performance, we have now added the ability to Hyper-V to be able to just take a storage device from the host and add it directly to the virtual machine, so it has complete ownership of it. Now, this is quite complicated to do. We have a series of blog posts that actually step through the whole process for doing it. But if you're in a situation where you need the absolute top storage performance, this is a great option to look at. We've also been doing a whole lot of work around evolving and improving Hyper-V backup. And I'm going to do a terrible thing and just say, I'm not going to talk about this much. The summary is you should definitely be talking with your backup vendor of choice and asking them, hey, do you support the new Hyper-V backup architecture? Because here's a hint, we've been working with all of them. So if they come back and they're like, what are you talking about? Then your backup vendor of choice hasn't been talking to the Hyper-V team, and that's kind of a problem. But most of them should come back and say, yes, we've been working with them, and we have some great new offerings. The final thing that we've done in the storage space is some investments around REFS. And I'm going to switch across to demonstrate this, because this is honestly one of my favorite demos, which is a terrible thing because it's a boring demo, but I love it because I'm kind of a nerd. So we've been working on REFS for a while now, and for a long time, we haven't really had anything that we could point to and say, that's why you care about REFS. Now, REFS is an incredibly intelligent file system compared to NTFS. You know, NTFS was designed before virtual machines were a thing. And there's a lot of concepts that NTFS doesn't understand. And in Windows Server 2016, we've actually started to be able to light up some really unique scenarios on REFS. So to show this to you, I have this system set up where I have a C drive that I've booted off, and I have an N drive which is formatted NTFS, and I have an R drive that is formatted REFS. And they both have the same files on them. They have a parent VHD and a differencing VHD on each of them. So that's all that's on there. So the first thing I want to do is I'm going to go ahead and I'm going to create a fixed-sized VHD on the NTFS partition, and I'm going to measure how long it takes. So as I mentioned, NTFS isn't, and we're creating a 10 gig fixed VHD, NTFS isn't a very intelligent file system. It was designed in the late 90s. So to create a 10 gig fixed VHD, we have to go to NTFS and we have to manually write out 10 gigabyte of zeros. And this is what is happening there. So 23 seconds of me going right out of zero, right out of zero, right out of zero, right out of zero. Now, most everyone I know who's worked with Hyper-V has had the experience of falling asleep in front of their computer while waiting for a fixed VHD to be created, because NTFS takes its time. REFS, however, has a lot more intelligence, and it actually allows us to go to it and say, hey, REFS, can you find us 10 gigabyte of zeros and put it together in a file for us? And it can go, yep. Takes 1 second. Because REFS understands the concept of where all the data is on the file system. But the one that I really love is what happens when we look at merging virtual hard drives. So this happens when you delete a checkpoint. It also happens as part of backup. It happens actually surprisingly frequently. So on NTFS, when I merge a hard drive, we are literally having to go through the child differencing disk, read a byte, and write it to the destination. Read a byte and write it to the destination. And what this means is, one, it takes time, but two, while this is happening, if you look at the hard drive light on my laptop, it is on solid. Like, we are absolutely thrashing the hard drive right now because we're currently going through about 6 gig of data, read a byte, write a byte. And that took 30 seconds on this system. Side note, I'm really happy. I got a new hard drive, and it is fast. On my old hard drive, that took 69 seconds. But what happens if I do, and I have the same files on my REFS partition, and same operation, I'm going to merge the differencing disk into the parent disk, and it's going to take 2 seconds. So what on earth just happened? How did that take 2 seconds? Well, the key thing to understand is no data was copied. Because we were able to go to REFS and be like, hey, you got these 2 files. We need a new file description that is just the combination of those 2 files. And it was able to go, okay, and return a new file descriptor that describes the file to us without actually moving any of the data. So I think that is really cool. That gets me excited. And I'm badly running out of time, so I'm going to have to skip over my next demo block, and we're going to have to race through this. I said we had a ton of features. So what about graphics? Well, we've made investments in graphics in 2 completely opposite directions. I love this little section of the deck. We've made a number of investments in remote effects. This is our 3D graphics acceleration for desktop and VDI solutions. We now support remote effects on Generation 2 virtual machines. We've increased our level of compatibility with OpenGL. We allow you to assign more video RAM. We've added new protocols to the RDP protocol to allow for better performance on streaming video. Now, jumping over, we also, for really extreme, just like we support direct device assignment for storage for NVMe, we also support direct device assignment for GPU. So if you have workloads which need pure raw GPU performance, whether it's like AutoCAD, whether you're doing number crunching, so on, you can now do all of that. Jumping over to the complete other end of the spectrum, we also now support having headless virtual machines. So if you're trying to get the highest number of virtual machines on a system possible, and really reduce the memory footprint, running Nano Server, and don't have a graphics adapter. It will use slightly less memory for running it. There's then a whole bunch of stuff that we've done for operational efficiency. One of my favorite features in the release is PowerShell Direct. This is where we allow you to get PowerShell remoting straight to a virtual machine with no network configuration, and in fact, no configuration whatsoever. Just jump in on the host, enter PS session, -VM name of VM, you're in there. It is amazingly powerful for scripting and automating Hyper-V. So really cool functionality. One of the things that we've built on top of this, which I think is very interesting for enterprises where there's high levels of security controls and for hosters, is we've built the ability to do PowerShell Direct and JEA. So the scenario to imagine here is, let's say I have a virtual machine that's running on someone else's infrastructure. I want the person who runs that infrastructure to be able to do Windows update things and to be able to fix my network adapter if I break it. But I don't want them to have access to my files. Well, what I can do is I can create a JEA profile and say, I'm going to expose this over PowerShell Direct. And I'm going to give the host system administrator the credentials that they need so that they can just do these specific actions and not give them full access to my system. We've also done some basic work where we now make it easier to figure out which network adapter on the virtual machine setting is in the virtual machine. Almost everyone I know has had this problem where you have 2 network adapters, they're connected to different physical networks, and you're inside the virtual machine trying to figure out, like, wait a second, which one do I enable the DHCP server on? If I get this wrong, it ends poorly. We now allow you to go through and assign names to network adapters in the Hyper-V settings, and you can access those names inside the virtual machine. We've made a number of improvements to Hyper-V Manager. The particularly interesting ones, we now fully support providing alternate credentials. So if you're logged in on your desktop, you've got Hyper-V Manager, you've got a handful of servers you want to connect to using different user credentials. You can go in and specify those. We allow you to connect to Hyper-V servers just using their IP address. So you don't have to have name resolution working. in order to do remote management. We've also done a bunch of work around making Hyper-V Manager better on high DPI devices like Surface Books. We've done work for cross-version management. So Windows Server 2016, Hyper-V Manager can manage 2012 or 2 and can manage 2012. Similar story with PowerShell. We now allow you to do multiple version management with PowerShell. Some big changes that we've made around how we do servicing of integration components with Hyper-V. In the past, integration components were a virtual CD drive that we would inject and get up and running. With Windows Server 2016 and going forward, integration components are delivered through Windows Update. Now a little story, and I know I'm running over time. Well, I'm not over time yet, I will be soon. But I love this story, so I have to tell it. When we were looking at doing this, we did have a big concern about how is this going to work with customers. We know we have customers who have disconnected data centers. And for those of you who have disconnected data centers where your hosts don't have access, don't worry, we have all the documentation on how you can get these updates and apply them manually without having an internet connection. But when we first started looking at this, I took someone on my team and I said, I want you to go out and I want you to meet with customers and I want you to ask them how they update their integration components inside the virtual machine. And ask them how they would feel about using Windows Update. And I was keeping my fingers crossed, I was expecting about 80% of people to say they'd be okay with Windows Update and 20% of people to have issues and we could work through those. Instead, what we saw was 80% of people said, what are integration components and am I supposed to be keeping them up to date? So that really made us go like, okay, we want to do this through Windows Update. So as I said, I'm going to skip over the demo slide. This is the final section, some of the core platform. I was talking about NanoServer at the beginning of this week. We've done a lot of work to get Hyper-V running on NanoServer. I do want to be really clear, you should be using NanoServer as your Hyper-V host. You really should. And this is kind of my warning. Next time I come out to Ignite Australia, if I find people who are not running NanoServer as their Hyper-V host, we're going to be sitting down and talking, and I'm going to be like, what's going on? It is a great Hyper-V host, and it has a lot of benefits and advantages. Another great change is we have nested virtualization. You can now run Hyper-V inside of Hyper-V. This is incredibly handy for people doing demos like me and with labs and so on. It's also one of the main reasons we invested in this is so that people can run Hyper-V containers inside of Hyper-V virtual machines. So lots of really cool technology there. We've made changes to the way virtual machine configuration files are stored. I am running out of time, so I can't go through the details as to why. Just know that there's a different file extension. So instead of having the .xml and the .bin files, we now have the .vmcx and the .vmrs. I believe this is second last. We've made a number of changes to power management to make power management work better on your Surface laptop, is the rough summary. And I'm going to jump through 2 slides. And the final thing to call out is we've continued to invest in scale. So once again, Windows Server 2016, industry leading in scale across the board. Largest hosts, largest virtual machines, largest scale numbers. So with that, I have 1 minute left. And in my last minute, I do want to call out some great online resources. If you go to aka.ms/virtualization, that takes you to all of our online documentation. If you go to aka.ms Hyper-V 2016 MVA, that is an 8-hour Microsoft Virtual Academy where we go through everything that I just discussed in 8 hours instead of in 75 minutes. So with that, we are exactly at 9:30. And I would like to thank you all for your time. If you have questions, please feel free to hunt me down outside. I see our next speaker standing impatiently up the back, so I want to get off the stage so that they can get set up. So thank you all.